Welcome back, everybody. Today, we'll be looking at trigonometry for AS level, especially the graphs and identities. So let's get started. A few identities that we need to know are radians and degrees. We're all familiar with degrees, which goes from 0 degrees to 360 degrees. And then we have radians, which is represented in short form by RAD over here. And we know that one full revolution has 360 degrees, and one full revolution also has 2 pi radian. So 360 degrees is equal to 2 pi radians. And using this information, we can calculate the radians. We can convert radians to degrees and degrees to radians. For example, we have 15 degrees over here, and we're converting that to radian. So 15 times 2 pi over 360 degrees, and leaving it in pi form gives us pi over 12 radian. Next up, we have sine. Sine of the first thing we need to know is the range of values for a sine x function. The sine x function ranges from -1 all the way to 1 inclusive, and the domain is more than negative pi and less than pi, or by converting it in degrees form is more than negative 180 degrees and less than 180 degrees. Next up, we have cosine. The function cosine x is defined from more than negative 1 to less than 1. So these two ranges are always going to apply for cosine x and sine x functions. The domain for cosine x, again, is the same as sine x, which is more than negative pi or pi radians and less than pi radians, or in degrees form, negative 180 degrees, or x is more than 180 degrees, negative 180 degrees, and less than 180 degrees. So sketching the graphs. So all the graphs have fixed shapes. You need to know the shapes and memorize them. They're not that difficult. And when sketching, we need to only look at a few key points. So this is the basic function of a sine x graph. So y will be usually given as a sine bx plus c in brackets plus d. So a sine function is in red because this form applies to all other graphs, sine, cosine, and tangent. They'll be usually represented in this form. The only thing that changes is this function over here. So it could be a cosine bx plus c plus d, or a tangent bx plus c plus d. So a represents the vertical stretch or reflection in the x-axis. If a is negative, it will be a reflection in the x-axis, and b represents the horizontal stretch or reflection in the y-axis. C represents the horizontal transformation, and D represents the vertical transformation. So I'll give examples for all these in the next few slides. So first things first, I apologize for the poor drawing or like the poor sketching, but I wanted to give you guys an understanding of from a hand-drawn diagram as compared to using decimals. So sine x, this is a function for sine x. It goes as such, it's a wave, as you can see, and there's 4 distinct points on this graph. So you will notice that the sine x intercepts just the sine x function where a is 1, b is 1, c equals to 0, and d equals to 0. It intersects the x-axis at 0, pi, and 2 pi. And it has peaks at 1 and -1 respectively. Hence, it fits, like I said, the range is from more than negative 1 and less than 1. So as you can see, all the values lie between negative 1 to 1. Okay, so as you can see by the shape, there's 4 x-intercepts that we need to know, which is pi over 2, pi, 3 pi over 2, and 2 pi. I've given this in radian form. This can be easily converted to degree form if you'd like. So that'd be 360 degrees, 180 degrees, 90 degrees, and 270 degrees. So first of all, it will go up, form a curve as such, and come down and go to the peaks. So so what does this graph actually showcase to us? So as we know that all add sugar to coffee, we know the acronym. We know that all trigonometric functions are positive here, and sine function is positive over here. So as you know, it starts from 0. This is pi over 2 or 90 degrees. That's the first quadrant, which is represented by this graph. And when it reaches pi over 2, it has a value of 1. And again, we know sine is positive at this in this region of the quadrant, which is the second quadrant, which is from 90 degrees to 180 degrees, or 90 pi over 2 to pi. And then we have t and c, which is where tangent and cosine is positive, and we know that sine is negative for that. Hence, the graph goes below the x-axis. Sorry, below the x-axis. So that's how you understand what you're doing using your graphs. This has helped me understand what I'm doing. I hope it helps you guys understand. But let's get back to sketching. I have restricted this graph's domain at 2 pi. However, this graph will repeatedly move on in a wave-like form unlimitedly. And this is in the x positive axis. And however, it can further continue from on the negative x-axis as I've drawn over here, where this is supposed to be negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And take note that the peaks have been swapped. It goes below the x-axis first, and then it comes up to form this shape. So take note of these points. And that's the generic shape of a sine x function. So next up, I have my first example is for sine x over 2 plus 3. So there's a lot of things that's happening here. First things first, there's a vertical stretch, or you could write out all the information in this form, will help you. There's a vertical stretch, there's a horizontal stretch, there's no horizontal transformation, and there's vertical transformation. So first things first, what I like to do is to find out the period. So let p equals to the new period, and p equals to 2 pi over b, where b is half. So take this as a formula that you must memorize, and you get 4 pi. So now we know that, as we know before, the first period of the sine x graph was 2 pi, and we divided that into 4. That helped us draw it out. So we have 4 pi now. Now I put it on the x-axis as 4 pi, and then I divide it into 4, which would be pi, 2 pi, 3 pi. Take note that the domain of this graph is up until 5 pi, so you must plot 5 pi as well. Next up, once we have plotted the x-axis and we know the period, we can now calculate the maximum and minimum points. So the maximum point can be found by taking value of A plus the value of D, which is 4 plus 3 equals to 7. And the minimum point is obviously, like I said, the graph is the graph is stretched in the vertical axis. So since it's 4 sine x, it'll be the peaks would be at 4 and negative 4. However, there's a vertical stretch by moving the graph up. So it's negative 4 plus 3, and 4 plus 3 giving us 7 and 1. Now, this is not required for you to put in your examinations, but I like to draw my new x-axis. So, which is at 3 now because the graph has been shifted up. These helps me put the points down. So once you have all of this, you place the first point, which is at the origin, or now, since it's been moved up, it's at 0, 3. And then we have pi 7, 2 pi 3, 3 pi negative 1, 4 pi 3, and 5 pi 7. So then you can just finish the sketching by drawing a curve that goes as such. So next up, we have another graph, which is y equals to negative 2 sine 2x plus pi over 4 minus 1. So let's look at what's happening over here. There's a vertical stretch and a reflection. Notice that this graph starts from below, and this goes up first, then goes down. However, in this case, it goes down first and then goes up. Next up, we have a vertical transformation and a horizontal transformation, and the horizontal stretch. So, like I said, a equals to minus 2, b equals to 2, c equals to pi over 4, d equals to minus 1. So first things first, find out the period by dividing 2 pi over 2, which gives us pi. Remember that the domain is to fit the graph in the given domain. So we know the period is pi. So now we have to divide pi by 4, which gives pi over 4, pi over 2, 3 pi over 4 pi, and then it repeats all the way until 2 pi with pi, 5 pi over 4, 3 pi over 2, 7 pi over 4, and 2 pi. So those are the four x values that we need to know, which is similar to this graph. Next up, we we do the vertical shift by moving. Since it's a negative shift, it moves to -1, and there's a vertical stretch. So first find the max point, which is 2 plus -1, which gives us 1, -2 -1, which gives us -3, and then we know that it's been shifted down, so the new x-axis is at -1. It helps me to, sorry about that, it helps me to plot the points. So first things first, now let's look at the points in pencil first, which is over here, 0, which follows, this is before the horizontal shift or horizontal transformation. So I would leave the horizontal transformation for last. So, I'll give you a few tips first. First things first, find out the period. Second, find out the vertical stretch and leave transformation to the last part, because the shape of the graph doesn't change. It's only the graph is being shifted up, down, left, or right. That's not that difficult to do. So first things first, get the shape of your graph correct, get the maximum points and the x-intercepts, all that correct, then you can shift the graph. So that's what I did first. I found the period, like I said, then I found the max and minimum points. I plot them in pencil. Then for max and minimum point, I already incorporate the vertical transformation because it's helpful in that case, and I leave horizontal transformation to the end. If you remember, in our previous videos, we covered transformation. If it's a plus sign, it means the graph is being shifted to the left. Hence, you shift the entire graph by -pi/4. So as I've done that, you see each point has moved towards the left by a value of pi/4. I do that in pen. I did that in pen. In your examinations, please use pencils and just erase the previous dots. But I left the pencil points in to explain in this video. Then you can just connect the graphs as such. All right. So when I'm drawing this, I've already considered the reflection across the x-axis. All right. So before the reflection took place, your graph will go up first. However, after the reflection takes place, the graph is reflected about the x-axis, and each point will be flipped. So your graph, if you can follow my cursor, your graph will go as such. It will go down, intersect at pi-1, come back up, so it will go down, come back up to 2 pi 3, go up to 3 pi 7, come down to 4 pi 3, and then go back down to 5 pi -1 if it was reflected across the x-axis, or in this case, y equals to 3 axis. In this case, it's been reflected along the x-axis. So again, you have to flip it. Again, it's been transformed to the left by pi/4. So if you follow my cursor, in this case, it goes down first, then goes back up, and then comes back down. So that's how you deal with sine graphs. Now we'll be moving on to cosine graphs. So this is a rough sketch of a cosine graph and the shape that we need to know. Unlike sine graphs, which start at the origin, cosine graphs start at 1. And then they go down and they intersect at pi/2, and then -1 is when it's pi, and 3 pi/2 is 0, and 2 pi is 1. Again, just like the sine graphs, you need to know the 4 x-intercepts or the x values. It has 2 x-intercepts, in this case, it has 2 maximum points and 1 minimum point. This graph will follow the same way in the negative axis, and these graphs continue on forever. So just remember the shape for cosine x graphs. So now we have 2 cosine x plus 3. In this case, a is 2, so there's a vertical stretch of 2. There's no horizontal stretch, as there's no horizontal transformation, and there's a vertical transformation of plus 3. So first things first, since the period has not changed, you can put the points down on the x-axis. Remember to check your domain. Remember to check your domain, so you don't make mistakes and you don't miss out on key details of your points. So we know we have to divide 2 pi into 4. So we have 2 pi/2, 3 pi/2. However, you must include 3 pi. So we have 3 pi and 5 pi/2 in the middle. And then from -pi to a -pi/2. Again, we know that it's been transformed by a stretch by a factor of 2. So the maximum point will be 2 plus 3, which is 5, and the minimum point will be negative 2 plus 3, which is 1. And then we know, again, I put the new x-axis, or like something to help me put my points. I drew it in dotted lines, and then I put the 4 points that I need to know using the cosine graph shape, and then I just sketched the curve in. So that's how you need to know. If you ever get confused, you could just put some points into your calculator. For example, 2 cosine x pi over 2 plus 3, and it will give you values if you get confused. So first things first, use a graph that you already know. If not, if you get confused, you can use a calculator. Next up, we have tangent graphs. Tangent graphs are a bit weird, but again, they rely on full x values, which is pi over 2, 3 pi over 2, and 2 pi, which is the same as sine and cosine. However, the tangent graph has asymptotes, vertical asymptotes. So the tangent graph starts at the origin, and then it will go up and it'll form a asymptote at pi over 2. And then there's another asymptote, and this is the generic shape of a tangent x graph. This continues forever in the positive x-axis and in the negative x-axis. So that's all you need to know. Unlike tangent and sine x graphs, which have maximum and minimum points, tangent x graphs don't really have maximum and minimum points. So if there were to be any vertical stretches, it would be redundant because you can't really tell by the graph by itself. So you can just draw the same shape. And vertical transformations do take place on tangent x graphs, and even horizontal stretches in this case, they wouldn't really affect the graph as much. However, horizontal transformation will. Sorry about that. Moving on, so let's look at negative tangent 4x graph. And then we have a given domain of 0 to pi over 2. Right now, like I said, always find the period first. So we did 2 pi over 4, which gives us pi over 2. I put that on the x-axis. Sorry, this is supposed to be inclusive of. Hence, I've drawn it as such. So put 2 pi over 2 on your x-axis, divide that into 4. So you have pi over 4, pi over 8, and 3 pi over 8. For me, it helps to draw the asymptote dotted lines out. So draw them out, and then since it's been reflected across the x-axis in this case, we can just flip these graphs along the x-axis, and they will give you a shape as such. My asymptotes are drawn terribly, but I don't think you'll be graded down on terrible drawings as long as they're accurate. Okay, we have another tangent graph, which is x plus pi over 4. In this case, we have an horizontal transformation. So first things first, there's no change in period. So you write out 2 pi, 3 pi over 2, pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, and negative 3 pi. And then since there's a horizontal transformation with plus pi over 4, we know that the graph has been shifted to the left. So I drew the new period, or the new x-intercepts that we need to consider in pen. So we have 7 pi over 4, 5 pi over 4, 3 pi over 4, pi over 4, and then so on and so forth. Again, like I said, I draw the asymptotes at points that we need to know. And then since there's really no change in the graph, we can just fill the rest of the shape inside by following this. Take note that this is from 2 pi inclusive to negative 2 pi. So you must showcase the edges where it gets cut off. So in this case, it will go all the way and form a asymptote. And in this case, it's forming an asymptote. It's a bit faint because of the lighting, but we can still see it. So that with that, we've come to the end of drawing graphs. I hope you were able to understand how to draw all the graphs and all the key points that you need to know. Remember all your stretches and transformations and your identities that you need to know. Thank you so much for watching. Please give this video a share, give it a like, and please comment in the section. Put your comments and opinions in the comment section. I'd like to take a look at them. Thank you so much. Goodbye.